Hey guys, welcome back. As promised, we are going to incorporate a top of rack switch to the mix. So I'm going to go ahead and I'm going to start him. And let me get my connection up to him. Okay, good. So let's see if we can view this in a way where we can kind of see what's going on. Alright, perfect. So let's just slap a configuration on him pretty quickly. You know what? We'll start with the, I take that. Let's start with the top of rack switch. We'll go up to the cores and we'll get the basic port channel functionality going. So let's give him a host name of DC1 top of rack 01. So the two interfaces we want to incorporate are 1 and 2. Okay, so let's do interface range E01 to 2. Now this right here, by the way, this is a product of EVE-NG. When you connect, this is a basic layer 2 iOS device with a Nexus. You're going to get a duplex mismatch. So what I normally do is just duplex full. This is a nuisance. Every time you start to switch, you're probably going to get this issue. But you're just going to have to get in the habit of typing duplex full because it doesn't stick for whatever reason. But just type duplex full and you'll stop getting pestered by the mismatch there. What we're going to do is we're going to say switch port mode trunk, which fails because we have to do switch port trunk encapsulation.1q, switch port mode trunk, and we'll do spanning tree port fast trunk. Okay, fine. So we're gonna put these in a channel group, which, remember, it's locally significant to whatever device you're on. So in this particular case, it's most likely going to be the only port channel we have because it's just connected to the cores. So we'll give it channel group 1 mode active. That should be fine. Now we have to go into interface port channel 1 and we've got to basically do all the same commands. So switch port trunk encapsulation.1q, switch port mode trunk, and we'll just give it a description. We'll say, PO1 to core switches. Okay, so that should be fine. So if we show ether channel summary, obviously we wouldn't expect this to be up quite yet because we have not configured the cores. Okay, so let's do that. Let's configure the cores. So if we go to core 1 and we look at show run interface ETH12, it's got nothing on it, right? So let's go ahead and do description. We're going to say DC1 top of rack 01 E0/1. So we know where it's going. We're going to do switch port. We're going to do switch port mode trunk. Okay, and then we're going to do channel group. We already have one going between the switches. We're going to need another one going up to the firewall. So maybe that's 2 and maybe this one's 3. So let's say channel group 3 mode active. Okay. So let's show run interface E12. So we've got our commands. So we can effectively take these two, put them on core 2. So interface E12. We'll blast those two commands there, and the only thing that's going to change is the description, which is going to go to E02. So we'll adjust him. Okay, and then, so sometimes you'll see it hangs a little bit because it's an incomplete configuration as of right now, because what we got to do is we have to tell it it's a virtual port channel, not just a normal port channel. So in order to do that, we have to go into the port channel that was just created. So if we show run interface port channel 3, okay, the only thing the port channel 3 same story as Catalyst or Next or iOS. You have to tell the port channel, you have to give it the same commands, right? So go under there, and we got to say, in this particular case, it is a VPC. We hit the question mark. So it's a VPC, and we have to give it the number. So in my opinion, there's no reason to make the VPC number any different than the port channel number. You should just keep them the same. There's no reason to overcomplicate things. So I'm just going to type VPC 3, okay? And we'll give the description of the port channel as well. We'll say port channel 3 to DC1 top of rack 01, okay? Now, if we show port channel summary, okay, right now port channel 3 is there, but it's down, okay, and the interface is suspended, okay? It's never going to come up until we finish the configuration on core 2. This is the problem here. So remember, we're not just configuring this port channel between 2 switches, we're actually configuring it amongst 3 switches. So we'll keep an eye out. Let me maximize this so you can kind of see it live. Hopefully we'll see some action. So we've got show run interface E0 or 1/2. So we did the interface, but we didn't do the port channel yet, right? Correct. So it creates the port channel 3 based on this command, but now we have to configure port channel 3. And again, the only thing we just kind of have to match what's over here is we just need the keyword VPC3, okay? So I'll give the same description in this case, and I'll do VPC3, and let's see if something happens, anything. So from top of rack's perspective, we can see it's doing something, right? So top of rack switch, we can see we just got a console message that said port channel 1 change state to up, so that's a good sign. So when we scroll up, before it was switched down and the links were suspended. So let's hit the up arrow, and we can see that as of right now, it's up. We see E01 is bundled in the port channel, and E02 has a W. So what's W mean? That means it's waiting to be aggregated. So okay, so we'll give him a minute to see if he can figure himself out. So it's doing all the negotiation, it seems. So on core 1, let's do show VPC. So now, when we show VPC, we have more than just port channel 1. We now have port channel 3, okay, or I should say VPC3, which is tied to PO3. It's up, success, success, and it looks like we've got some active VLANs. Now remember, we haven't configured any VLANs aside from the 999, so I don't expect to see anything there. You know, we're not going to until we configure something, right? So let's see what core 2 shows. Okay, so core 2 now has VPC for VPC3. We see up, success, success, so we match, right? Both core switches are in agreement that VPC3 is up and working. Let's just check top of rack one more time. Okay, good. So now top of rack switch has its 2 interfaces are bundled in a port channel. So this doesn't look any different than what we've been doing repetitively throughout the series, right? Like every time we've done a port channel, this is the same exact output, because we're kind of faking top of rack switch 1 out in a sense that it's going to 2 switches, not 1, but it has no idea. It wouldn't know the wiser, right? Like it just thinks it's connected to a single switch. Again, the magic is being done between these cores with the power of virtual port channels. So that's a great sign. Now we've got no way to verify any connectivity or do anything because we haven't assigned any VLANs or addressing or any of that stuff yet. We're just building the blocks or laying the foundation for the VLANs to be able to traverse these devices. let's just go ahead. In this video, since it's a short video right now, let's just power on the 2 servers, and we'll configure. We'll get a VLAN in place, and we'll attach it to those ports, and we'll slap some IPs on the servers. And then the next video, we'll get into the gateways and first hop redundancy protocols and that kind of stuff. So that'll be a fun video. Maybe we'll actually be able to do some like failure simulations and stuff too. So let's put the blocks in place for the moment, and we'll switch gears after that. So let me. Okay, good. So let's hop on. Let's bring everything in one window. So let's get on server 1 and let's get on server 2. All right, good. And then based on our key, we've got a lot of VLANs to play with. It doesn't really matter where we start. We could put both of these in VLAN 100. I mean, I think we just use 2 VLANs just to kind of go inter VLAN connectivity. Why not? So let's make server 1 VLAN 101, and we'll make server 2 VLAN 102 because it's kind of easy to remember. So let's do show IP. So we've got nothing. So let's do, this is server 1, right? So we'll do IP 10.101.101 for VLAN 101, and we'll make him 11/24. Okay. Oops, I gotta put the gateway in there. Sorry about that. 10.101.101. All the gateways will make .1. That's fine. Actually, we'll make the gateways 254. Okay, we'll use the last IP in this /24 subnet. So all the gateways that we configure, they'll be 254. Okay, so let's change that. All right, so he's got an IP address on 101. So let's do server 2. We'll say show IP. He should have nothing. IP 10.101. He's going to be in VLAN 102, and he'll be .12 since he's 2. I try to make it easy. And then his gateway is 10.101.102.254. Okay. And then let's just throw the ports 1 and 2 in those VLANs, and then we'll break and hop to the next video. So if we show VLAN brief on top of rack switch 1, we don't have any VLANs, right? So let's go ahead and create VLAN 101. We'll say name. We'll say servers, whatever, 101. Okay. And then we'll go into interface E11, and we'll say switch port mode access, switch port access VLAN 101, description. We don't need to say link. We'll just say DC1 server 01. Okay, and we'll do spanning tree port fast. Okay, so now if we show VLAN brief, we have server 101 VLAN created. It's attached to 1.1, which is great. So let's just quickly do the same thing. VLAN 102, name, servers 102. We'll go into interface E12. We'll say switch port mode access, switch port access VLAN 102, spanning tree port fast, and we'll do description DC1 server 02. Okay. And now if we show VLAN brief, we should see both VLANs assigned to both ports. However, remember, right, the key point here, believe it or not, if I put them in the same VLAN, I should be able to ping between them even though I haven't defined a gateway, okay? That's just because it's going to ARP to the switch. The switch will know where that other IP address lives based on the 2 ARP messages. It'll tie the 2 together, and it'll basically send that, make that connection happen between the switches. It'll do all that without a gateway. At least it should work. But in this case, since I did 2 separate VLANs and I have not defined the gateway on the switches yet, it should not work. And just for, you know what, just for fun, let's just test the theory, right? Why not? Let's have some fun. So let's go over to server 2. Let's just change his IP really quick. So we've just put him on VLAN 101. All we got to do is flip the port on top of rack ETH12. We're going to say switch port access VLAN 101. Okay. So now when we show VLAN brief, we should see 2 ports in 101. So now let's just, for fun, ping 10 101 101.12. See that? So it works. Even though there's no default gateway defined anywhere in the environment, we can still pass traffic between the 2 servers. That's great until you need to reach something outside of your VLAN, and then you're stuck because there's no gateway. So I just wanted to demonstrate, just because, you know, that's just your very basic layer 2 functionality, right? So let's just put him back. So we'll put him back in VLAN 102. And then interface E12, switch port access, VLAN 102. Okay, show VLAN brief. Okay, good. So now we're back to normal, which is where we want it. So now we'll take a break. When we come back, we'll do the gateway configurations between the cores, which is going to introduce a first hop redundancy protocol. In our case, we'll use hot standby routing protocol, or HSRP. And then, you know, maybe we can even do some failure simulation. We'll take one link down to the primary HSRP node, and we'll see how the failover works and all that stuff. So next video should be, you know, a little bit more fun, interactive, and we'll see if we can break some things and see how it handles it. So I will see you guys there.